Welcome back. We are in Algebra 1. The unit is called Quadratics Multiplying and Factoring, and we're on the second skill, multiply monomials by polynomials, basic area model. Okay, so here's our first question. A rectangle has a height of 3 and a width of 3x squared plus 4x. And that is shown here visually. So we have a rectangle, and it is a composite of two rectangles. There's this blue one that has height 3, width 3x squared, and the pink one, height 3, width 4x. So together, that combined width is 3x squared plus 4x. That was this polynomial. This is a monomial, 3. It's also just a constant because there's no variable. So what I would like you to think about is what would happen if x gets bigger or smaller, right? So if x increases, 4 times x is also increasing. If x increases, x squared is increasing exponentially, and it's being multiplied by 3. So if you increase x, and it's positive, this rectangle is going to get longer and longer and longer. If you decrease it, at some point, it will collapse and you won't have a rectangle anymore. We'll come back to that in another video, but for now, let's do what they say. Express the area of the entire rectangle. The expression should be expanded. Okay, we'll talk about that. So the area of a rectangle, remember from geometry, is the height times the width, or length times width. So one dimension of the rectangle times the other gives you the number of square units that it's made of. So in this case, 3 times 3x squared plus 4x. That'll look like this. 3 times 3x squared plus 4x. And we use the distributive property to put 3 times each of these. So 3 times 3x is 9x squared. 3 times 3x squared is 9x squared. And 3 times 4x is 12x. So this area right here, this expression of the area is true, but this is what they mean by expanding. It means get rid of the parentheses and have it be just one polynomial in its simplest form. In standard form would be a good idea. So you put the highest exponent monomial first and then descend from there. So we'll write 9x squared, 9x squared plus 12x. Make sure we wrote what we meant to write. The computer believes whatever you tell it. And we'll check our answer, and off to the next one. A rectangle has a height of 4x and a width of 3x plus 1. Express the area of the entire rectangle. The expression should be expanded. All right? So 4x is our height times 3x plus 1. Again, the distributive property so that we can expand this. 4x times 3x is 12x times x. 4x times 1 is 4x. And we can write x times x as x squared. So 12x squared plus 4x is our solution, and we'll want to write that in the space that they provided. 12x squared plus, what did I say? 4x. 4x. And we're done with that one. Next one. A rectangle has a height of 5 and a width. Now we get a trinomial. That's 3 monomials. 4x squared minus 2x minus 6. So each of these rectangles has an associated width, 4x squared, negative 2x, negative 6. They want us to find the entire rectangle's area and expand it. So 5 times 4x squared. 5 times 4x squared is 20. 20x squared, that's the first rectangle. 5 times negative 2x is negative 10x. Now that's kind of an interesting idea because that means that this rectangle actually, if x x is positive, then that rectangle doesn't exist and it's kind of a negative area, which is a weird concept, but we'll go with it. Keep in mind here that it's this rectangle that needs to exist in order to have an area. So one way to think of this is that you might have these two positive areas, if they're positive, and then you take off whatever that other rectangle is. But anyway, we're going to do what they said, expand this, multiply and expand. So 5 times negative 6 is negative 30. So my first rectangle's area is 20x squared, second one is negative 10x, and the third one is negative 30. So x would have to be large enough to make this rectangle larger than the combination of those in order for this rectangle to actually exist. And we're done.